Problem number 10 says the enthalpy change for the reaction N2 plus 3H2, both are in gaseous states, plus gives 2NH3 gas is 92.38 kilojoule at 298 K. Find the internal energy change at 298 K. So, this is the opposite or reverse of the problem just we discussed. So, here for the reaction N2 gas plus 3H2 gas gives twice NH3 gas, Ng products is 2 Ng reactants, number of gas in the reactants is 1 plus 3 gives 4. Temperature is given 298 K, delta H is given is minus 92.38 kilojoule. So, if we convert this into joules, we get minus 92.38 times 10 to the 3 joules. So, we know delta H is delta U plus delta Ng at T, delta Ng times at T. So, delta U is delta H minus delta Ng at T. Now, if we substitute the value of delta H, delta N, R, T, etc., we get delta U is minus 92.38 times 10 to the 3 joules minus delta N value is delta N is N reactant minus N products minus N reactant. So, we get 2 minus 4. So, 2 minus 4 gives minus 2. So, this is minus 2 times R is 8.314 and T is 298 K. This is in joule unit, everything is in joule unit. So, if we further carry out this one, we get delta U is the actual value of delta U is minus 87.425 kilojoules. So, this was problem number 10. Now, we move to problem number 11. It says enthalpy of combustion of carbon to carbon dioxide is minus 395.5 kilojoule per mole. Calculate the heat released out on the formation of 35.2 grams of CO2. Okay. So, here we know the reaction is C solid plus O2 gas gives CO2 gas, and delta H value is given here minus 393.5 kilojoule per mole. So, if we convert this into joule, we get 393.5 times 10 to the 3 joule per mole. This is the value of delta H. Okay, so, heat released for the formation of 1 mole CO2 is minus 393.5 times 10 to the 3 joule per mole. Now, 1 mole here, right? So, 1 mole means 44 grams of CO2. So, we can calculate the heat released released for the formation of of 35.2 gram of CO2 is minus 393.5 times 10 to the 3 joules by 44 times 35.2. So, we get, if we calculate this one, we get 314.8. Okay, so it says is combustion process and heat is getting released, the sign will be reverse here. So, this is your plus and this is plus. So, we get this is in kilojoule per mole. This is in kilojoule. Okay, mole is not required here, or kilojoule. So, this is your 314.8 kilojoule. The sign becomes plus because heat is released here. Problem number 12 says 98 kilojoule of heat is supplied to ethanol and temperature rises by 3 Kelvin. Find the heat capacity of the sample of ethanol. So, the expression of heat capacity we know. So, what is the definition of heat capacity? Heat capacity is Q, okay, heat required to raise delta T temperature. Okay. That is the definition of heat capacity. So, heat is given 98 kilojoules, so 10 to the 3 in joule unit and 3 degree. So, delta T is 3. So, 3 Kelvin. So, we get 32.6 times 10 to the 3 joule per Kelvin. This was very simple problem. Then question number 13 is a swimming pool is holding 10 to the 5 liter of water. How much energy is required for the temperature to rise from 40 degree to 45 degree? The specific heat capacity of water is given. So, C of water is given, C or specific heat capacity of water is given 4.184 joules per degree Celsius per gram. So, this is given in gram and the volume of water is given in liter. Okay, so, if we convert, so volume of water is 10 to the 5 liter. So, it gives you 10 to the 5 and liter is 1000. This is cc. Okay, so we get 10 to the 8 cc. This is the volume of water. Now, considering the density of water is 1 gram per cc. Okay, so density of water, because we need to get the amount of water, because the in gram or weight of water or mass of water. Okay, so we need the density. So, density of water we consider 1 gram per cc. So, the mass of water is 10 to the 8 times 1 gram. So, we get 10 to the 8 gram. This is the mass of water in the swimming pool. So, what is Q? So, okay, Q is mCV delta T, okay, or here C we can write. So, m mass, so mass is 10 to the 8 in gram, and then C is given, value of C is 4.184 in joule unit, and delta T is 5. So, delta T is 45 minus 40, so gives you 5 degree. So, this is 5. So, you get Q is 2.0, so 2.092 times 10 to the 6 kilojoule. So, this is the heat supplied. Problem number 14, it says 0.562 gram of graphite stored in a bomb calorimeter in oxygen at excess condition at 298 Kelvin and 1 atmospheric pressure. It was burnt according to the reaction C plus O2 gives CO2. During the reaction, the temperature changes from 299 Kelvin to 299.80 Kelvin. Here the heat capacity of the magnitude calorimeter and that of the contents is 20.7 kilojoule per Kelvin. Calculate the enthalpy change for the above reaction at 298 K and 1 atmospheric pressure. So, we start with what is the quantity of heat absorbed by the calorimeter. So, quantity of heat absorbed by the calorimeter is Q by, if we say this is C, so C is Q by delta T as just we discussed. So, Q is C times delta T. So, the value of C is given, C is 20.7 times 10 to the 3 in joule unit, and then delta T value is also given 0.80. Alright. So, if we multiply this, you get Q, value of Q here. Okay. So, value of Q will be 20.7 times 8 times 10 to the 4 joules. This is the value of Q. Now, heat produced by burning (0.562 gram of graphite is minus of Q. Okay, so you get minus 20.7 times 8 times 10 to the 4 joules. So, heat produced by burning so in the reaction 1 mole is taking place, 1 mole of graphite. So, burning 1 mole of graphite means 12 gram of graphite is minus 20.7 times 8 times 10 to the 4 times 12 by 0.562. Okay, so thus enthalpy of, so this is nothing but the enthalpy of combustion. Thus, therefore, enthalpy of combustion of graphite is minus 20.7 times 8 times 10 to the 4 times 12 by 0.562. This is in joule per mole. Okay, so you need to just calculate this quantity. Next problem is, if water vapor is assumed to be a perfect gas, the molar enthalpy change of vaporization of 1 mole of water at 1 bar and 100 degrees Celsius is
41 kilojoule per mole. Determine the internal energy change if 1 mole of liquid water turns vapor at 1 bar pressure at 100 degrees Celsius, and the problem B says 1 mole of liquid water is converted into solid ice. Okay, so we solve the part A first. Okay, so for part A, H2O liquid goes to H2O gas, right? So delta H is delta U plus delta Ng RT, that we already know. So what is delta Ng here? Delta Ng is 1 minus 0, so we get 1. Okay, so delta H is, we get 41.0. Again, delta H value here is given. So delta H here, heat of vaporization is given for 1 mole, 1 bar is 40. So delta H is also given here, is 41 kilojoule mole inverse. So we get 41 times 10 to the 3 joule mole inverse. So you get delta U is delta H minus delta Ng RT. So you get 41 times 10 to the 3 minus 1 times 8.314 times 100. Sorry, T is 100, means your 373 Kelvin. Okay, so that is the value of delta U in joule per mole. So you need to calculate this quantity here. That is the value of delta U. Now part B. In part B, H2O liquid goes to H2S. Okay. So delta Ng is 0 here, because the molar volume of liquid and solid, they are very much comparable. So delta U here is nothing but delta H. So you get 41.0 kilojoule mole inverse. So this is also very good problem.